If you have ever tried combining multiple Excel tables using VLOOKUP and then build calculations like revenue or profit on top of the data, you know how messy and difficult it can become. In this video, you'll learn how Power BI connects datasets using relationship and how to create calculations using DAX, including calculated columns and measures and functions like related.
Okay, does anyone know what are we having here now? What do we have? Like, what's this? And what's this? Any IT people?
Yeah, it's one-to-many or many-to-one. It's
correct.
Yeah.
Correct. Do you know what is this thing?
That's the direction. So it's saying
correct.
that. Yeah.
Yes. So one-to-many or many-to-one, based, how you look at that. So that's right. But what does it actually mean? Let's have a look at it. So if I go to my country table, in my country table, if you remember, we had some duplicates, right? But we got rid of the duplicates by removing the duplicates from the combination of country and city. So in this table, we only have one instance of a city. You only have one instance. So it's one. But in the sales table, I can actually have many sales in that one city. So I will actually have many instances of a one single city in sales table. If I can go here and I can just click on the city and I can select any city, let's say city. I have about 163 sales in Sydney. So Sydney is not one instance here. So one Sydney connects to 163 instances of Sydney in the sales table. So that's really one-to-many. That's the default relationship. And as I said, data model is definitely a complex topic. It's a very broad topic. But just if you are starting out with Power BI, if you just play by some of the good practices without even understanding them in details, you will be doing the right thing. So some of the good practices are, if your relationships are one-to-many, that's fine. If your cross-filter direction is single, that's fine. Although you have other ways of changing the filter direction, but when you get into that space, you also need that level of understanding so you're not doing the wrong thing. So what I mean is we have many different kind of relationships, essentially one-to-many. So if I double click on the line, if you double click on any line, it will open up a dialog box for you. So this dialog box shows you how sales table retailer city is connected with country table, which is, you can actually see this dark gray column. That's how it's connected. Cardinality is like a jargon they use to say it's a many-to-one or one-to-many. If you click on the drop down, these are all the other relationships. Many-to-one, one-to-many essentially is the same thing based on how you look at it. One-to-one means one instance of city gets connected to one instance of city in other data set. Many-to-many is an interesting one. So this cardinality was not available in Power BI before, when really Power BI started, and we had to kind of solve this problem. How do you connect two data sets where we don't have a one-to-many, where we don't have a one-to-many relationship? So we used to create like a bridge table. Again, it's a different topic, but now this cardinality of many-to-many is there. You're allowed to establish a relationship between two data sets where you don't have one-to-many, but you also have to be careful that you really understand what happens behind the scene when you establish this kind of a relationship. So it's not part of this course that we go into many-to-many, just as a part of a caution that when you establish these kind of relationships, make sure you understand what happens. Many-to-one is pretty safe. Then we have cross-filter direction. I can change it to single. I can also have a both. If I click on both, it changes and it actually shows you that it's now both. This is an indication that this is both and this is single. As a default, as someone who is starting with Power BI, single is safe. Both is also fine if you just understand why you're doing and what are the implications. So what it essentially means is really a filter flows from this table and filters sales. Country table filters sales table, and product table filters sales table. That's what this direction really means. And we are also going to see visually with an example, like what does it mean when a filter flows from one direction to another. So as a default, filter flows from one side of the relationship to many sides of the relationship. And these are some of the rules that I would really encourage you to write it down. As a default, I'll also write down a few things in the chat. As a default, filter flows from one side to many. So default / safe scenario is one to many and single cross filter relationship. So essentially we have 4 cardinality, one to many to one, one to one, many to many, 2 cross filter direction, 1 single and both. But this is really the ideal scenario that you should be aiming for when you are establishing your data model, and your data model keeps on evolving from this point on to have like 10 tables in a single data model. Okay, so what do we mean when we say that the filter flows from country table to the sales table and not vice versa? Let's actually see it in action, and then you will be able to have a much more concrete idea what I mean. So I go to my filters pane, and I think you don't really need to follow this part. This is more for your explanation. Once we start with data visualization, that's where I will give you an opportunity to just experiment with some of the visual, but this is more for the elaboration, so you don't need to follow. So what I mean is, now I have 3 data sets. I click on sales, I have my quantity sold, I click on quantity sold, and I will just turn it into a matrix, or let's say a table. So this is the total quantity of all the products that I've sold, right? And I click on country, and let's say I put a country here. It gives me a breakdown. It gives me a breakdown of all the quantity which is sold in a specific country, and you can now see that country is coming from country table and quantity is coming from quantity table. So I'm picking these 2 fields from 2 different data sets, and because of the relationship, it just works. Now country table, now Australia, which is coming from a country table, filters my sales table and shows me the right value. So country table is filtering my sales table to kind of slice and dice my quantity sold into different buckets or filters, you can say. But what if I want to see something like this? What if I want to see for every country, or for every product, how many cities are we kind of selling it into? So what I mean is, if I select a city from the country table, so these are list of all the cities, and I want to count number of products sold in every city, and I go in my product table and I go for the product code and I kind of change it to a count. It does not give me any value. It just gives me 118 is the total number of products that we have. It's not filtering. My country table is not filtering my product table. It's not, filter is not passing through to the product table. And now you can actually see why. My country table passes the filter to sales table, but because of the direction of this filter, it does not get passed through to the product table. So it does not work. If I will change the relationship to double, now city will filter my sales and sales will filter my product. And you can actually see how you have different values. So total 47. So out of all 118 products, 47 products are actually sold in Basel, 50 products are sold in Calgary, and so on and so forth. You can just, and you can actually see, the numbers change. Change it to single, the filter will not pass. This is still a very basic raw understanding of the filter direction, how it actually affects your calculation. But this is what essentially is happening. What is the danger of having double? Because when you actually saw the double, you would say to yourself, calculation does not work for a single, it works for double. Why shouldn't we have double for all these connections? And that's usually how people start. When they start with Power BI, they make all these connections as double. But when you start making all these connections as double, you open yourself up to the exposure of what we call a circular referencing, that a filter passes from here and then back to the table. Power BI will start giving you all sorts of errors around, this data connection is not possible because of your circular referencing, and you will not be able to kind of continue scaling and evolving your data model, because any connection that any new data set that you will bring and make part of your data model, and you establish a connection, it will just keep saying that you have a circular reference. So just be careful. Don't make that as a starting point. There are some other inefficiencies which happens when you make it a double. So if you have a really big data set and you make it a double, it's not as efficient as a single one. So just be mindful of some of these limitations that we have. Okay, let me just stop here, and I'll just take any questions if you have around data modeling. It's the same thing, Sanjay. One to many or many to one is really the same thing, does not really matter. It depends upon how you look at it. If you click on it, if it puts my sales table on the top and country table at the bottom, so it gives you many to one. If it puts country table on the top, sales table at the bottom, it's one to many. It's really the same thing. Just depends upon from what perspective you're looking at it. Any other question, guys? So that's a brief introduction of your data modeling. Let's have a look at some DAX. So DAX is your Excel function equivalent in Power BI. DAX is one of the most complicated things that probably I have learned in my life. It's very simple when you start with it, but then it grows to get really, really complex really quickly. So in Excel function, you can create a calculated columns. You can also create a calculated columns using DAX. So let's create some columns that you can, have a reference point with Excel. So go to your sales table, and we are going to create some additional columns here. And can someone identify what do we call this step? So we started off with data transformation. Then we did some data modeling. Now, what are we doing? What do we call this step? Great, Bhavin. Yes, that's right. Data enrichment. We are enriching our data sets with few more fields that does not really exist in the data source, and we are calculating it ourselves. So we have unit price and quantity sold. I can just multiply my unit price with quantity sold, and it can give me, you can call it sales, you can call it revenue. So let's start from there. So you click here, and then you right click. When you right click, it gives you an option of new column. Click on new column. And now just a little, not a glitch, like it's a behavior of Power BI that you should be aware of. So it gives you a new column, but if I click here, the new column kind of vanishes. See, I'll show it to you again. Create a new column. If I click anywhere outside, it kind of vanishes. So what you have to do is once you create a new column, you don't have to click anywhere outside. You have to go and click in the formula bar. And once you click in the formula bar, let's write the function now. So it's, how Excel functions work with a cell reference. DAX works with a column reference. If you have any experience working on tables in Excel, you would know what I mean. So you don't have to select a cell like A1 plus B1, you have to select a column. So in this case, my column is price. Start writing price, and you can actually notice, Power BI IntelliSense window. And by IntelliSense, I mean this help which pops up is fantastic. It gives you everything that starts with essentially, PRI, all the functions that contains PRI, all the fields which contains PRI. In this case, I'm interested in sales table unit price. So what I'll do is I will write price. Just use my arrow keys to go there and hit a tab, just showing you in like a faster way to write function. So write price, scroll, use your arrow keys, go there and hit tab key. Tab will complete that, will actually just put that word in the formula bar. Multiply is your multiplication is your static. And then I want to multiply this with quantity sold. So I search quantity and then hit a tab. Once I do it, I can hit enter. And once you do, you can just type it. You can just rename the column to sales. Let's call it revenue. I think revenue is better because name of the table is also sales table. So let's call it revenue. Now we will calculate the total cost. Now the challenge with total cost is we do have a quantity sold, but the cost of the product is not in this data set. Cost of the product is in the product table here. So how do we do it? So I need to multiply quantity sold with the product cost, which is in product table here, to get the total cost. We are going to add, we are going to create another column, right click, new column here. Now I will write cost. And as you will write cost, you will realize that you cannot access a column which is in an other data set. It does not give you an option to do that. But there are some functions which allows you to do it. And name of that function is related. You can think of it more like a VLOOKUP. You're actually doing a VLOOKUP in your sales table because the relationship is there. It just allows you to access it. So related. And as soon as you write related, now you start seeing product cost. See this? Just give me a thumbs up if this works. Now you select product cost, close the bracket, and hit enter. It gives you cost of the product. That's your product cost. And you can simply multiply it with quantity sold to get total cost of a sale. Because if you're selling 83 quantity, you multiply the unit cost by 83, and it gives you total cost, like cost of sales, cost of goods sold, you can say. And that's your cost of goods sold. Let's call it COGS. So very similar to Excel, just a bit of a different syntax. Can we now calculate profit from here? It will be a simple revenue minus cost of goods sold, and that will give you revenue. That will give you profit. Revenue minus cost of goods sold, and that's basically your profit. Done. Can we also calculate profit margin? So profit minus, profit divided by, which is our / revenue. Let's call it margin. And you can format this as a percentage, which is right here. right here, percentage. So you're getting a percentage row by row. Let's do one last function of if, because if is also one of the popular function in Excel. You can use the same kind of a logic in Power BI. How is my table sorted? My table, I think it's just sorted by date. Let me just sort it by date. Yeah, now it's sorted by date. So now your values should probably match. Just sorted by date now. Let's create a simple if function. Let's say if the amount of sales is greater than let's say 50,000, it's a big sale. Otherwise, it's a small sale. A very simple logic to categorize our sales into big and small. Just so you know, your if function works with exactly the same logic. New column. If your revenue is greater than 50,000, then big sale or normal sale. Sale category. Let me give you one small challenge, like a quick test, and tell me who can actually do it. So we have our cities in my sales table. I want to create another column by saying if, so we have in Australia, we have Sydney, Melbourne, and Brisbane, I guess. So I want to say if country of sale is Australia, then it's a local sale. Otherwise, it's an international sale. But just remember, country column is not there in the sales table. Country column is there in the country table. So see if you can write that. And if someone can write that and paste the function in the chat, that would be great. Rishi, good question. Not anymore. This is not data transformation anymore. Data transformation, but recorded in a way that because data enrichment follows your data transformation, so all of this will still stay saved in your Power BI file, but it is not saved as a M script code in your query editor. If your data source changes, all the calculations will change as well. And what I can do is I can actually show it to you by an example. So for example, like this sale, which is 1st of January 2016 in this city that I don't know how to pronounce. If I change the value and revenue goes below 50,000, this big sale will automatically change to normal sale. Has anyone been able to do column if related country table is local normal? That's right. Perfect. Yes, that's exactly right. So I'm going to create a new column. And what I want is if country is equal to Australia. So if I write if, but now I cannot select country because country is not in sales data. So what I'll do is I'll write related, and then I can select country equals to Australia if, and close the bracket. My bad. If country equals to Australia, then it's local. Otherwise, it's international. And I'm using related function to kind of fetch the value of the country, which is coming from my country data set. This is it with DAX. But I also want to tell you that there is another thing you can do with DAX, which is much more complex than the column. So right now what we are doing is, so we can actually do two things with DAX. We can create a column that we have been doing now. We created a revenue column, cost of goods sold column. We can create columns with DAX. We can also do one more thing with DAX. We can also create a measure. And measure is something which is very, very non-intuitive for Excel users. But measure is something which gives superpower to your analytics process. But then you actually need quite a lot of understanding of what happens in the data modeling space, and some of the related concepts to really make use of a DAX measure. We will not really go into the details of DAX measure, but just for the sake of knowing how it looks and what it does, we are going to create one to DAX measure, and then you can just have a look for what's the difference and how it actually makes things much more useful. So we have a profit column, right? What I can do is I can also create a measure for profit. Right now it's a column. And let me show you one more thing. See this thing? This is an indication of a calculated column, this little icon there. And you also have this icon, which is more like a summation sign. If you have this icon, it means this is a numeric value. And once you put that in a visual, it will summarize. This is obviously, as we know, this is more like a geographical kind of category. So it shows you a map. And this is a calculated column. Let's create a measure. Let's create a measure together. So it's a profit column. Let's create a measure. So how do you create a measure? So you click here. See this new measure here? Let's click on new measure now. And I will write sum. And as I said, I will not go into the details of why we write a different syntax, because obviously it requires some foundational knowledge, but we are just going to test it out. So sum revenue minus sum COGS. Close. And just to differentiate, I will call it profit CM. CM stands for calculated measure. So sum of revenue minus sum of COGS, and enter. Where did that go? You just don't see anything here. You don't see any numbers. You don't really know what happened when you created the measure. It does not go anywhere.
Nothing happened for me.
Nothing will happen, Luke, and that's the idea of a measure. And as I said, it can be a bit non-intuitive for Excel users, because measure is nothing but just a formula. But if you will see in your table on the right, you will actually see this calculator up here. Do you see this calculator? So we have this profit CM measure, and as you can see, this measure is not getting calculated anywhere. It only gets calculated when you use it into a report or a visual. Let's say you want to create a bar chart and you use a measure, or you want to create a pivot table and you use a measure. Only that time it gets calculated. So it gets calculated on the fly. It does not become part of your data source, and hence it's much more efficient with the memory. It does not occupy space to get saved. Let's have a look. If you have this measure, go to your data visualization, like the top part where we create visuals, and we are just going to see something. This is your matrix. Your matrix is your pivot table, this one right here, this one. So select this one. This is essentially your pivot table. So once you select this, you have rows, columns, and values. This is where you put the calculations, like the numeric values. These are your rows, just like your pivot table. So let's say country into the rows. So what I do is I click on the country, hold, drag, and leave it on the rows, and you will start seeing all the country names here. And then you hold, drag, and put values here. Profit column. And you can also hold, drag, and put profit CM in the values. So you can actually put it side by side. So you can compare the results of a profit column and a profit measure side by side. You only see values calculated by a measure when you put that in a visual. In this case, we are putting it in a matrix. And you can see the values are same. You see quite a lot of decimal points at the end. We can format it to only show 1 or 2 maybe, but again, the values are same. So what I'm doing is I'm actually getting the benefit of the calculation without occupying the space in the data source. So that's where measures become much more powerful. This is one of the use cases. There are many other benefits of measure. There are a few things you can only calculate by a measure. You cannot even do it with a column. But then it's definitely an advanced topic we are not going to cover today. Okay, let's format it. As you see, we see quite a lot of decimal points that we don't want to see. I click on the profit, like what I want to format. On the top, I see column tools. When you click on something, you see column tools on the top. And here, you can decide how many decimal points you want to see. Come here, I can say 2, enter, and it changes to 2. And same, I can click on profit CM, 2, enter. Okay, so that was a bit of an introduction of DAX, DAX columns, DAX measures. For rest of the day, we are going to spend time exploring the visuals, what I call as the fancy part of business intelligence, is developing the report based on the data model that we have, and then how do we share it,